Now someone had bought some pylon tech batteries. I don't know how to spell it, I don't care. And they bought them and they were 3.5 kilowatt hours of battery. Now they looked at the kilowatts of the battery. Now this is completely useless to most people, because when you've got a battery, it doesn't matter what battery it actually is. Now this may have a charge rate, a C rating, and this makes a huge amount of difference to your power and performance from the battery. Now if I had a little tiny 1U, you know, the size of a pylon tech, small slot type device, I know that it's probably got 30 amp hour batteries in it. And what they've done is they want to make, it's got 16 of them, equals 48 volts. Now to do that, that means they're 4 in series and 4 in parallel. Now as you chain batteries together to bring the voltage up, this amperage remains exactly the same. So the only thing you can get out of that is less than, actually it's less than 60 amp. So you'd only get 60 amps. So what we can do is we can go 60 amps and then we can multiply that by 48, which will give us a total power of 2,800 watts. And that is the maximum performance you can get from that battery. That's all it can deliver. So if you've got a 4 kilowatt inverter, it won't power it. It simply can't. And it doesn't matter how many of them you have in series, you're still limited to 60 amps, or less than 60 amps. So you could run a 3 kilowatt from it, and it'll just fall ever so slightly short. And as that voltage drops, the current rises. So as the battery gets more flatter, the current's going to rise until it hits its 60 amp peak, and then you're going to start losing power because your voltage goes down. So when you're buying batteries, you need to have a C rate of 100 amp hours, and typically this is done on over 100 amp hour batteries, but that's really running them at peak power, and that will diminish their life down. Or you want to get something like a 250 amp hour, which will give you 250 amps. So if you've got 250 amps and you're running them in series, you're still going to get 250 amps. And 48 times 250 is 1012 kilowatts. And that can be the peak power that people actually use in their home. Now, we've talked about power generally used, and that's averaged over the time. But if you go and turn on your kettle with a smart meter, you'll see that that's 3.5 kilowatts. And this 2,800 isn't going to cut it. Your cooker, about 5.6 kilowatts. Your washing machine, about 3 kilowatts. So your inverter needs to have peak power performance, and you need to be able to give that battery enough amperage and current flow to your inverter so that you can actually power all your items. So I hope that makes sense, that when you're picking your batteries, you need to go for the right type of cell inside the battery. If you don't have the right type of cells, you're going to be pulling too much power from them. They're going to shorten the life down. You're going to cause them to overheat, and you're going to eat away at that money that you've put in for that investment. Now back to the array calculations, and that's both array and battery calculations. We've looked at a 70%, 80% and a 50% state of charge or discharge to bring up the life of the batteries. But we've also got to consider the amp hour C rating of the batteries, what their total discharge and charge rate are going to be over time. And 100 amp hour batteries are quite big, and you're going to probably need those if you're actually going to run your home. And in fact, you may need to go up to a 250 amp hour to really push through the amount of power you're going to need. Now, we've looked at 250 amp hour batteries providing 12 kilowatts of power. Now that can be quite good if you've got a 6 kilowatt inverter. It's going to run most of your things in your home, and it's you'll be running them at half power at 250 amps, which is going to extend that lifetime and not stress the batteries out as much as you would expect. So I hope this has been informative. This is probably your first step into doing solar. So I hope you found that a little bit more informative, that the solar power requirements that you need are going to be based on your battery size and your total power consumptions. Now, it's not easy, and I probably haven't explained it really well, but you know, your solar during the day is going to produce you power. That doesn't really need to be in the battery, in the battery size that you take. So what you need to do then is to pick the right amount of array to charge that battery. Otherwise you're going to have yourself a flat battery over time, and you don't want to be pulling from the grid to charge it. Although in winter times in the UK you can expect to have to probably supplement your battery charge from the grid for about 90 days of the year. It's not going to cost you that much, probably about £18, but for what you'll save on panels and your battery size, it would probably be well worth it, because yeah, going for battery sizes are quite expensive if you don't buy from us, although we do have batteries now. The 4.8 Cylon-Tech battery for about £200 or £300 more, you can get a 7.2 kilowatt battery from us. But the point is though is that we use higher C-rating batteries, so that actually can produce the power from the units to the inverter to give you that power. Unfortunately, the small and compact, although that seems great, won't or cannot produce the power. In fact, a Pylon-Tech battery I'd probably only use on a 1.5 kilowatt inverter, because I think the draw on that's something like 57 amps. So you need to think about how your battery is configured, not its kilowatt hours but its C rating. If it cannot pull enough amps through it, or if you're maxing out the amps you're putting through it, it's only going to damage the battery more, shorten your lifetime down, which means then you have to replace your batteries, which are one of the most expensive things in solar these days. So I hope you found that a little bit informative. We're going to be doing some array things over the next couple of weeks. We were talking to Solar Farm 101 about multiple arrays and array direction, and we've been doing our own experiments here, looking at the arrays. I have a split array. I have a summer array and a winter array, and these focus on the sun's direction because I don't face south. And so I have one morning array which covers the sun, and someone else has done a evening array, so that we can actually have a look at what the power is like between the mornings and evenings. And quite often is the case, it's better to have them in the morning rather than in the evening. So that'll make a difference between your east and west facing, if that's the case with you. Now we have some almost horizontal for our summer array that is under inspection as we're coming now into summer in the UK. but unfortunately most of the monitoring equipment blew up the other day when we chucked too much power for it. So we're building our own charge controller which will give us our power readings and everything else like that. Once it is built, it will need to be calibrated. That will probably take me ages to do because it's not a manual, it's a software calculation. So if you did like this video and you found it informative, you're thinking about solar, there is other ways of doing it. If you want to even save more money, you can get a reducer that we do, which just contributes during the day to your power needs and will cut out all your daytime power use, general power use, and it may actually make excess in quite a lot of cases, but what it does do is it saves you a lot of money, and the return on investment is about 200 days. So yeah, keep on this channel. We're going to go into lots of things about solar. You'll find other solar things. Go on the playlist and find off-grid and solar, and that will give you all your solar needs. If you're into big DIY, I'm also going to be releasing more information on our solar charge controller MPPT and how to build your own. And it's not that complicated if you want to give it a try. Hopefully you'll subscribe or like the video. Leave your comments down if you've got any questions about batteries and calculations and such like. Do put them down in the comments, or if there's anything wrong or you want anything explained in more detail, I'm sure me or somebody else will fill you in. Thanks for watching.